Example 11, yet another limit. We have the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. Once again, an equation or a function or whatever that we're trying to evaluate a limit, and you might be thinking, I just don't, like, where would that one even come up? There is a specific reason. It's just that I must keep it a secret until the next chapter. Until then, hey, when we're evaluating these limits, what's the first thing that we do? That's right, we directly substitute in our x value. So in this case, it's 0. Let's go ahead and directly substitute in, well, that's not notability, 0, and see what happens. See if we get an indeterminate form or something that is determinate. If I plug in a 0 across the top, I get the square root of 0 plus 1 minus 1 over 0. The square root of 0 plus 1 is 1. 1 minus 1 is 0. And there it is. We have our indeterminate form. And I'm understanding this as on the graph, there is a hole. There's a point of discontinuity. And my goal here is to try to fill that hole in by finding a function that agrees with this one at all but one point, everywhere except 0. And so how am I going to do that on this one? Well, the strategies that we've used so far were factoring. I'm not sure there's anything that we can possibly factor on this. We've got a square root and a minus 1. There's nothing to factor there. Okay, then we also had expanding things out and simplifying, but there's nothing to expand out or simplify. It's not like you can break up that square root in any kind of way. So we need a totally different strategy, and the strategy on this one is rationalizing the numerator. So you have done rationalizing the denominator before, and what that means is you have a square root on the bottom and you multiply by something so you can get it up top, because you were told for so long that we don't like to have square roots in the bottom. But here, we don't like to have square roots in the top, and we need to get it down to the bottom. And how do you do that? How did you rationalize the denominator before? You did that by multiplying by a conjugate. And we're going to do exactly the same thing. And it looks sort of like this. Let's bring down our limit notation. Limit as x approaches 0, square root of x plus 1, minus 1 over x. And our conjugate of the top would be the square root of x plus 1 plus 1. And if I multiply by that on the top, I need to multiply it on the bottom, because what I'm essentially doing is multiplying by a fancy 1. When you multiply by 1, you don't change the value of something. When you multiply by a fancy 1, you still don't change the value of something. You just change how it looks. You're just basically rearranging it in a very convenient way. And that's what we're going to do here. So across the top, you remember what happens when we multiply conjugates. Like the middle term is supposed to cancel out. It's sort of like the difference of two squares. And so you do want to expand out that top. So I'm going to have the limit as x approaches 0 of, when I multiply this square root of x plus 1 times this square root of x plus 1, the square roots will cancel, giving me just x plus 1. The middle term cancels out. I don't have to worry about it, but I do have a minus the last terms being multiplied. So negative 1 times negative 1 gives me a negative 1. Negative 1 times positive 1, yeah. On the bottom, I always want to leave that in factored form. Don't expand this thing out. So I'm going to leave that in factored form. Something's going to cancel. It's going to be so satisfying, as you will see. So square root of x plus 1 in parentheses. So now across the top, I can see I have plus 1 and minus 1, which get to cancel. Wait, that needs a pink crayon. There we go. The limit as x approaches 0 of x over x times square root of x plus 1, and one more time. I have a common factor across the top and the bottom of x. That leaves a 1 up top. There's also a 1 on the bottom. We usually don't write it. And we have the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. So let me ask you a question before I go to evaluate this limit. What's the relationship between this function here, 1 divided by the square root of x plus 1, and the square root of x plus 1 minus 1 all divided by x? What's the relationship? It's not an obvious one, but because of the algebra that we just did here, these two things should be exactly the same everywhere except at 0. This one is filling that hole for me. And I'll show you that just to visualize that thing. We can see that on the graphing calculator in a minute. So now it looks like we are at the point where we can directly substitute this in. 1 over square root of 1 plus 1, no, not 1 plus 1, it's 0 plus 1, plus 1 is equal to, and on the top I get 1, on the bottom that's the square root of 1 plus 1, gives me a 2. Looks like this thing is approaching a half. So let's pull up that graphing calculator and verify this. So when we're working these problems on our own and we want to, like we're not quite confident in our answer, that's one of the things that our fallback is always pull up that graphing calculator and verify that. And yet again, I'm going to have to split screen this so that I can see both of these things. Bear with me now as I figure out my iPad here. Okay. So on the top, in parentheses, square root x plus 1. Get out of the square root, but still in the parentheses, minus 1. And then out of the parentheses, divided by, and it's just an x on the bottom. And hit enter. All right, so here's this function over here. Let me go full screen. Maybe zoom in on a little bit. It's a very strange function. And does it look like it hits 0.5? It does, doesn't it? It looks like it goes right through that 0.5. Of course, there's a hole right there on that graph. I can't see the hole because it's just a tiny speck. And for some reason, not that it actually mattered, I forgot to hit my y equals on that one. Still graphed it though. All right, so on the bottom, it's y equals, and then I have 1 divided by, let's see if I remember it. I'm gonna take a chance here and make this parentheses square root x plus 1, arrow out of it, and then plus 1. Boom. So you can see that purple graph directly overlapped the green graph because they agree at all but one point, and that one point was the hole that we just tried to fill in.